test will be here before you knew it. So, solve. It's like grade 8 algebra, grade 12 style. Okay, what could be better? And there's a couple of options on how you may want to do this. So let's do this two different ways. Does someone see a relationship between 27 and 81? Yeah, 9 goes in both of them, so does 3. Okay, let's write this as an exponential equation with a common base. So as an exponent, what would 27 be? And you got to think to yourself, can I also have the same exponent on 81? And in grade 10, I probably told you, 27 is one of these fabulous numbers, right? Because we introduce cube roots. There is something multiplied by itself 3 times to give you 27, and that magic number happens to be 3. So that means 3 to the power of 3 is 27. Okay? Can 81 also be written as a power of 3? One more 3. 3 to the 4 is 81. Okay? So 27 is that, but I still have this thing. That's okay. I'm just going to put it right there. Okay? That says 27 to the power of 3 minus x. Same thing. 81 is 3 to the 4th power. So this says 81 to the power of 2x plus 1. So pure logic says 3 to the something equals 3 to the something, then that something must be equal to that something in perfect language. Okay? Right? If this is equal to that, and these are the same, then that's got to be equal to this. Okay? If it doesn't make sense, well, you got to memorize it. So these exponents have to be equal in order for this thing to work. Okay? And solve means, well, what is x? So now you know what to do. Now you're back to grade 9. I can distribute this unlike some logarithms. So 9 minus 3x is 8x and 4. Add 3x to both sides. Minus 4 to both sides. X is 5/11ths. Not a nice whole number, so it'd be pretty hard to kind of fudge this by trial and error, right? Might take you a long time, but it's possible. Could we check this? Would that be a good idea if it was your test? I think so. Kind of tricky, but if I go 3, actually, let's go right back up here. 27 to the power of bracket 3 minus, what's x? 5/11ths. I don't need brackets there because this thing will do bed mass. What is that? 4,400. So the left side is 4,400. Well, that better be equal to the right side, or that's not x. What is 81 to the power of bracket 2? What? Get out of here. Times x. Plus 1. Hey, when do you know it works? Okay? I'm happy that's the right answer. Okay, so that's one way to do it. Log base 3. Some of you guys are looking at that going, hey, I don't want to do that. I want to do this. How can I write 27 as a log base 3? Well, just like that. Take the log of one side. Whatever you do to one side, do to the other side. Okay? Now I want to solve it this way. What can I do with those exponents? 3 minus x and 2x minus 1. Use the power rule and chuck them out in front. Okay? So that is 3 minus x bracket log base 3 of 27 equals, this exponent's going to come out in front, 2x minus 1 times log base 3 of 81. And why did I want to use log base 3? Because I know log base 3 of 27 is what? Thanks. Not negative. That's 3, isn't it? What is the power onto which I put base 3 to give me 27? 3. What is the power I put onto 3 to give me 81? 4. And I got the exact same thing, don't I? So I'm not going to solve that, I already did. Okay? So when I give you a question like that, I don't care how you do it, just get the answer. Let's look at some others. Solve for x. Doesn't really tell you how. And sometimes, I mean, it's not always going to be a nice number here. Right? What do I want to do with this guy? I want to solve that thing for x. What is x to make it work? And you could do trial and error, but obviously we're teaching you how to do it so you don't have to, right? Well, what can I do first? Take a log of both sides? Is it some exponent I want to do? Or do I want to go back to grade 8 and do some grade 8 stuff to make it prettier? Do I have numbers on both sides of this equation? Like a 5 and an 80? Can I make it prettier? Can I divide that by 5 and get rid of it? Whatever I do to one side, do to the other side? Is that a nice number? How many times does 5 go into 80? Sweet. What next? Logs or exponents? I know what my mind sees. I see 16 as a power of 2. 2 to the what is 16? That's 16, isn't it? And if 2 to some power equals 2 to some power, then this power on the left has got to be equal to that power on the right. What's x? Yeah. Okay, you can use logs if you want. Hopefully you get the same answer. You should. Okay. Is there a relationship between 2781 and 243? I think we've already seen this, haven't we? That is 3 cubed. That is 3 to the 4th power times x minus 2. And 243, is it 5? Yes, but let's check. Okay, yeah. That's 3 to the 5th power times 2x minus 3. Actually, could I have divided both sides by 27 here? Because I know some of you guys still try to do that. Can I put 27 into this number? No, because that one's got an exponent attached to it. You can't do that, okay? One of you tried that about half an hour ago. Okay, what does this mean? What is this? When I'm multiplying with the same base, what do I do with my exponents? Yeah, and that's what I'm going to do. I'm multiplying with the same base. I'm going to add this to that. 3, and I know I can expand that, but let's just do one step here, okay? And then I'm right back with this concept, right? In order for the left side to equal the right side, I got the same base. That means these exponents must be equal. There's no other way this thing's going to work. So that, now I'll expand it. 4x minus 8 is equal to this. 10x minus 15. Collect your x's. Collect your numbers. I usually like my x's to be positive, so let's minus 4x on both sides. Yep. Okay, and let's bring all the numbers then to the left. So that is 15 minus 8, which is 7, and 3, which is 10. So x is 10/6, otherwise known as 2 goes in there 5 times, 2 goes in there 3 times. And I'm not gonna, but you should check it, especially if it's your test, right? Make sure you got it right. Make sure the left side equals the right side. Okay? Just got one more. Solve this puppy for x. Can I divide both sides by 3? Is that going to help me? Dana? Nope, no can do. Is there some exponent I'm going to use? 8 is 2 to the 3rd power, but that's not going to help me with a 5 or a 3, is it? No. So I can't use exponents here. It's not as nice as this guy, so it looks like I'm resorted to using this method, log. Okay? So I can't really do anything here first to make it nicer. I just got to take the log of both sides. Okay. So log of this side, that's the whole thing. And take the log of that side, the whole thing. Okay, well, let's just, you don't have to bracket that, but I may as well, just be consistent. Is there some base I want to use for that log? I don't know yet. Think about it. First, what do I do with this? Can I go log of 15 to the power of 2x minus 1? I'm sure one or two of you will try that. No, you can't, right? I can't collect these. This has got exponent attached to it. What's the first poster on our wall up here? Multiplication rule, which means I can split this up, right? That's log 3 plus log of that. 5 to the 2x minus 1 is, what can I do with this thing? Let's remove those brackets. I hate them. If you like them, feel free to put them in. take that 2x, put it out in front. Power rule. Okay? 2x log 8. I may as well do that here with this. So leave that like it is. This is an exponent. I got to put it out front. What did I forget to do here? Yes. That whole exponent, you got to put brackets there. Let me do that in a different color to emphasize. Okay, you have to do that or it's wrong. It's not 2x minus log 5. It's 2x minus 1 times log 5. Okay, now what? Is there some nice log base that you might want to use? I could use log base 3 here, and that would be 1, but does that help me here? Not really, right? And it doesn't help me here. So maybe I don't want to do that. I don't want that one necessarily simplified. Okay, I could use log base 8 here, and that would be gone. That would be 1, but then it doesn't help me here or here. Okay, there is a couple ways to do this question, and they do simplify to different things. But I'm just going to keep that as log base 10, I think, because I'm not sure what to do. What I do want to do is collect this x. So what do I do here? This you can distribute, right? That's 2x times log 5. Oh, I changed my color. That's okay. Minus log 5 is that. And I still got that. And I know I can put this in my calculator and make these things numbers, but they're going to be irrational numbers. Why do it? It's a lot harder to write that number down than what log 3 is, right? How do I collect my x's here? Well, there's an x here. There's an x there. Let's collect them on one side or the other. Which way did I do it here in my notes? I took this one over here. So, just so I'm consistent, you can put them on the right side. Shouldn't be that big of a difference. So if those are over here, I want to put that over there, and I want to put that over there. So that becomes positive log 5, and that one becomes a negative. Okay. Can I factor out a 2x from those two logs on the left? Yeah, that's what I want to do. Or maybe just an x. Like I want x by itself, right? Do you want to take 2x or x? It's up to you. I'm just going to take an x. Still got that. Last step, how do I get x by itself? Divide away all this garbage. And yeah, I could factor that 2 out. Whatever you do to one side, do to the other side. But why? I don't want to see any brackets today. Okay, that's what it is. Could I make it a number? Yes. Log 5 minus log 3 equals that divided by bracket 2 log 5 minus, whoop, is that right? Yeah, it is, thank you. I just saw that. Those aren't the same. That's a log 8. Log 8. bracket, bracket. That's what x is. Negative 0.543. Okay? So it did say solve. So I probably want a numerical value for x, right? As opposed to simplify for what x is. It's kind of rude. All right? Kind of tricky. And again, you might have a different answer, because I could put log base 8 here, and then it would be something different. And I would still solve it for x, and I would get the same answer, but it might look a little different, okay? In that case, that would be gone. It would just be a 2x. So there's a couple of different options here. That's how I would do it, right? If you can't really use a log base for everything else, then maybe you probably don't want to do it. Okay, that's it.